next presenter, Samartha A. Katte, design and analysis of multi-coupling reduction techniques in an antennas array.
Myself Samartha Katte. I am from MIT WPU Pune. My guide is Dr. R.S. Badade sir. These are contents: introduction, literature review, aim and object, design procedure of microstrip patch antenna, design of MIMO antenna, where mutual coupling reduction technique is used, types of reduction techniques, and performance parameters. First of all, introduction. To need of a modern communication system is to provide high data rate for the required application. Due to the increasing demand of the capacity, data rate in wireless MIMO antenna has existence. So single input, single output systems in which the data rate of efficiency is very low. Since these systems can fulfill the demands like high data rates due to limited bandwidth handling the capacity. This suffering from multipass and fadings like signal to noise ratio and signal to noise ratio of the receiver signal. Then that's why the MIMO antenna is used to receive the transmit and receive the signal to increase the capacity throughput of the system. For the smaller antenna is required for small device. For the smaller antenna antenna, we can use microstrip patch antenna is used. It is made up of a metallic patch of the attached to the dielectric substrate. Is also present on the side of the dielectric substrate. In that two or more patches are put it on the grounds, and two or more antennas put it on the ground. Some isolation will be happen. This isolation will be reduced between two patch antenna. So mutual coupling techniques is used. Literature survey. In that first paper, two elements S-shaped mutual coupling is used for polarizing the diversity, and the parasitic elements can be used. And second paper, there are E-shaped in that E-shaped or C-shaped both are parasitics can be used to resonating the frequency at 6.3 frequency. And third paper, in this paper different mutual techniques are used like DJS, neutralization, parasitic elements, and EEG and steps like these. And sorry, just a minute. Methods aim and the object. For the designing and mutual coupling reduction techniques, MIMO antenna can be designed. In that object, first of all, I can design pentagonal microstrip patch antenna at 2.4 gigahertz frequency, and then performance various of mutual coupling techniques like stubs, interspacing elements, and changes of length and width of the patch antenna. And the research platform. Then for this designing antenna designing, HFSS 15 64-bit HFSS research platform is used. Methodology. First of all, I will design 2.4 gigahertz frequency. In that 2.4 gigahertz frequency, a single patch antenna I can design. Then I can design 1:2 MIMO for the separate ground and common ground. And in that, for the mutual reduction techniques, interspacing elements and separate ground it can be used. After that, I can design 2:2 MIMO. That means four elements are added in that. Four elements are designed in that antenna. And once we can done with 2:2 MIMO, in that 2:2 MIMO I can use stub for the ground plane and performance analysis of MIMO antenna. How designing procedure of microstrip patch antenna. How to design the microstrip patch antenna? First of all, we can start, then select the substrate of the material. In that, then selection of the substrate, it can create the substrate material and ground. Then create the patch and feeding lines, like coaxial feeding techniques, insert feeding, like different types of feeding techniques can be used. Then assign the boundary extraction. Now once we can assign the boundary extraction, verify the design and model the parameters. It has okay for this, then HFSS simulation will be on. And then once it is no, then create once again the patch and feeding lines. Then result will be occur. What is a microstrip patch antenna? A microstrip patch antenna consists of radiating patch on one side of a dielectric substrate which has a ground and plane on the other side. For good antenna performance, a thick dielectric substrate having a low dielectric constant is desirable since for providing better efficiency, larger bandwidth and radiation. Because of the size of the dielectric tides, the wavelength of the resonant frequency. Microstrip patch antenna is a narrow bandwidth beamwidth. Feeding technique. Microstrip line feeding techniques are line feeding techniques, coaxial feeding techniques, aperture coupling feeding techniques, and proximity feeding techniques. For this my project, coaxial prop feeding techniques is used because of the widely used and easy to fabricate, and it can use a 50 ohm resistance. It will be given. Advantages of microstrip patch antenna: it has high performance and support both linear as well as circular polarization, and different shape can be easily attached into the microstrip patch antenna. Disadvantages: it offers efficiency due to the dielectric loss as conductor loss and radiation into the half of the space. First of all, I can design 2.45 gigahertz single patch antenna. For this single patch antenna, the return loss will be minus 14 dB. The reflection coefficient, there is a transmission line which will be gives the antenna transmission line having impedance Z0. Input impedance at the antenna is ZA. In load impedance is input impedance of an antenna. When the incident signal is because of a impedance mismatch, the reflection signal will be occur. Once the reflection signal will be occurs generating standing wave ratio pattern. In that standing wave pattern includes Vmax and V minimum. In that Vmax and V minimum, Vmax is happen in phase of the voltage, and V minimum will be occurring out of the phase. These are the graphs that 2.4 gigahertz. It will be given 14 reflection coefficient. S11 is minus 14 dB and bandwidth is 14 gigahertz. And VSWR, voltage standing wave ratio, will be between 1 to 2. It will be a standard. And effect of the ground, the antenna impedance and bandwidth characteristics are typically affected as a long antenna located in the center of the ground plane is sufficient large even if the antenna radiation pattern is known as affected on the ground. The feeding techniques, the width, once the ground width, once the width will be changes, the feeding point is location in the middle of the upper portion of the ground plane. If the feeding is located at the bottom portion of the ground plane of the coaxial couple to the trend of the existing of the plane. 1:2 MIMO. In as 1:2 MIMO, here two MIMO will be used. In that 2 MIMO having interspacing between lambda by 2. Here 1:2 MIMO having minus 15 to 15.30 dB as the reflection coefficient, and mutual coupling will be minus 25. The reflection coefficient of the 2.4 gigahertz is below minus 10 dB, and S1 that is mutual coupling, that is S12 will be above minus 20 dB in 1:2 MIMO. These are the opposite antenna. Here is the 2:2 MIMO common ground. In that 2:2 MIMO common ground, 2:2 MIMO ground, 2:2 MIMO ground. Here is 2:2 MIMO. In that common ground, there is no any correction. There is no any current flow the current flow from 1 to the second antenna is incidentally flow from one direction to another direction. There is no any polarization between diversity. Depends on the techniques can be applied to improve the mutual coupling, because each element several orthogonal ports. Then to produce the impress of the antenna element isolation, the purpose of the high gain antenna envelope correction deflection, and it can be used 2:2 MIMO ground stuff. In that 2:2 MIMO mutual couplings will be less for the 47 means it can be due to -49 to 29. Why we can use the stuff? The suggestion of 4 element MIMO element surface current distributed, the current will not be flow from one antenna to another antenna. It will be used only for this. This will flow from only one credit slot. High current will be adjacent patch elements. Therefore, common ground structure need to isolate approach to reduce the leakage current. And for this common stub is used. And these are the performance parameters of the MIMO antenna. Performance MIMO antenna is the correlation coefficient and diversity gain. In that ECC, in that coefficient envelope coefficient relations, the estimation for 3D radiation patterns of the antenna, ECC can be assumed by scattering parameters of the radiation pattern of the antenna. It will be a standard at 0.05. And diversity gain, the effect of MIMO antenna heavily depends on the diversity. The relationship displayed below can be used to calculate the diversity of the gain of the antenna. The purpose of the diversity gain is 9 dB for 2.4 gigahertz. Conclusion, for the 2.4 gigahertz, it can be minus 10 dB reflection coefficient, and VSWR is 2.4 gigahertz at 16 into 60 patch antenna, and we can use for design for 2:2 MIMO antenna, minus 49.01 dB for common stub and 49.80 it will be used for stub. These are the references. Thank you.
Thank you for your presentation, Samantha. Good work. Please share your details for anyone to have any queries. They can get in touch with you. Thank you.
Thank you, sir.
Now we will go ahead with the next participant. I call upon Gomati.
Good evening, sir.
Please go ahead. We can see the screen. Thank you. Try
Okay,
to restrict it for maximum of 6 minutes to 7 minutes.
Okay, sir. Good evening, everyone. The project title is Design of L-shaped slot antenna with a different dielectric material for WiMAX application. WiMAX is nothing but the worldwide interoperability for microwave access. Wireless deliberating. Why we are using the WiMAX means it is the high-speed internet to service. WiMAX uses the spectrum to deliver the connections by using the network. It is used to USB dial-ups and then Wi-Fi devices, laptops, and cellular phones. WiMAX is based on the principles of IEEE 802.16 standard family. In Wi-Fi network, access is only a few feet with the speed up to 54 megabits per second. But in WiMAX antenna, the ranges takes place 40 miles within the speed of 70 Mbps. WiMAX is a IP-based wireless broadband access technology. So we can use the WiMAX application. Then the abstract is, it is a multi-band and the patch feeds are involved in this process. L-shaped slot antenna can be used for the WiMAX applications. Here, FR4 substrate is used. FR4 means the flame retardance. The substrate 4 denotes the woven glass reinforced the epoxy resins. The length of the slot antenna takes place 20 mm and the width takes place 26 mm, and the thickness of the antenna is 0.008 mm, and the dielectric constant takes place 4.2, and the loss tangent takes place 0.018 And then the operating frequency takes place 1 gigahertz to 10 gigahertz. In this L-shaped slot antenna takes place 3.4 gigahertz. There are two types of the bands are involved in this process, S-band and C-band. S-band takes place 2 to 4 gigahertz and C-band takes place 4 to 8 gigahertz with the centimeter of 15 to 7.5 and 7.5 to 3.75. The antenna can be simulated by using the IE3D software, and the testing process can be taken over the network analyzer. By using this process, we can calculating the value of efficiency, VSWR, directivity, radiation pattern, return loss, and gain, etc. The main objective of this project is to design the proposed antenna structure and achieving the appreciable gain, directivity, and low return loss with the high radiation efficiency. The main purpose of using the WiMAX application means the antenna size is very compact with the dielectric materials. There are so many substrate materials are involved with the dielectric constants. Now we are using the FR4 as a substrate. The ranges takes place of 4.0 to 4.8. Why means to reducing the size of the antenna. It is the antenna design flowgram. First of all, we are taking the antenna design requirements. That is the nothing but it is a gain, directivity, return loss, radiation patterns are taken, and then it can be simulated by using the IE3D software. If the requirements are needed, the design process is finished. Otherwise, the process can be regulated until the value get. It is the flow diagram of L-shaped slot antenna. First of all, understanding the customer requirement, then specifications of the generation has been takes place. Then the antenna topology has been selected. After that, the modeling and the designing has been takes place. Then the operation has been simulated as per the needs. Then the protocol has been developed. After that, the testing and the resulting has been evolved in this process. Then the feeding technology. There are 4 types of the feeds are involved: microstrip line feed, coaxial feed, aperture coupling, proximity couple feed. When comparing the coaxial feed, aperture coupling, proximity, microstrip line feed is more when compared with other 3 these. Then the reliability is better than other 3 these, and the fabrication is much more easy when compared with the other 3 these feeds. Then the impedance matching is very much easy when compared with the other 3 feeds. Then the bandwidth range is takes place of 2 to 5%. Then the design equations, which involves the epsilon r denotes the relative permittivity is 4.2. Then H denotes the height of the antenna, W denotes the width of the antenna, epsilon efficiency denotes the efficiency in permittivity of the antenna. Then L efficiency is nothing but it is the length of the efficiency of antenna. L denotes the length, and BW denotes the bandwidth of the antenna. Then the gain of the antenna has been calculated. Gain indicates how strong a signal antenna can send or receive at a specified directions. Then the directivity is nothing but the ratio of the radiation intensity is given direction from the antenna to the radiation intensity averaged all over the directions. Then it is the radiation pattern of the antenna. Radiation pattern is nothing but it is the mathematical or graphical representation of the far field antenna. Then S parameter. There are 4 types of the S parameters are involved: S11, S12, S21, and S22. S11 denotes the output reflection coefficient. S21 denotes the forward bias, and S12 denotes the reverse bias reflection coefficient. And S22 denotes the output admittance of the antenna. VSWR is voltage standard waving ratio versus frequency. For standard waves can be ratioed in presence of voltage. Then it can be the value of VSWR takes place at the 3.5 gigahertz. It is the 2D and 3D view of L-shaped slot antenna, and it is a patch designs which involves the PCB board. It is a fabricated output has been taken. Fabricated output has been taken by using the network analyzer. The practical value takes place 3.5 gigahertz, and the theoretical value takes place the 4.5 gigahertz. And the experimental results, which shows the parameters such as VSWR, return loss, gain, directivity. when the return loss is when the gain is increases, the return loss is always decreases. It is the main process in this L-shaped slat antenna. Then the conclusion of this project is the present work was stimulated and fabricated based on the simulation performance and measurement. The new type of the multiple band slot antenna has been the desirable features such as the size of the antenna has been reduced and the gain has been increases, and the characteristic shows the very sharp. The frequency of operations has been changed by varying the dimensions. That's all. These are the some of the references I should take. Thank you, sir.
Thank you, ma'am, for your wonderful presentation. Well, yeah, good presentation. We'll go ahead with the next presentation. Before going ahead with the next presentation, I just wanted to check whether the following participants who I missed calling, are they present? Nahida Shafi, Dr. Manzoor Ahmad Chako, are they here? Joint intention, intent detection and slot filling by integrity.
Yes, sir, I'm here.
Yeah, oh, sorry. Your presentation is done, right?
Yes, sir, it's done.
Okay. I didn't miss it up. Sorry. Okay. So I just wanted to check whose presentation was missing. Okay. Yes. Then Sayali A. Kadam, face mask detection, are they here? Face mask detection, Sayali. Okay. Do we have Mohammed S. Makni, a review of the agency theory from theoretical perspective? Okay. Fatma, do we have a formulation of a hand sanitizer and its evaluation for antimicrobial activity? Okay, I'm just marking these people absent. I won't be calling them again. Okay, do we have Jalal Fadil, managing risks related to internationalization project in China? Do I have them here? Okay. So I just wanted to check. Do we have Harshad? Okay, Harshad is here. Harshad, the variable steering mechanism. Harshad, do we have Harshad here? Variable steering mechanism.
Yes, sir. I am representing in.
Oh, okay. Thank you for confirming.
On behalf of our team, I am representing.
Okay, wonderful. Thank you.
I hope my screen is visible.
Wait for a minute. We'll just conclude and check with other participants, and then you can present it, ma'am. Thank you. Next, do we have Ali Hussain? Ali Hussain, Farah Shami, are they present? A large-scale automated classification. Okay, I'm marking them absent. Ali Hussain, Farah Shami, Shahab, Dina Yusuf. Okay, I'm marking them absent.
Yes, sir.
Okay, are you there? I was just looking in the name. I couldn't able.
118031.
Okay. The name. Please rename yourself so that we will get to know. Because I was just checking who was the participant. Please rename yourself, sir. I just mark it present. Thank you. Next, I would like to call upon whether do we have Syed Javed Hussain, Shivkumar Ramurthy, study of column structure behavior with fiber and ferro cement. Do we have them here?
Yes, sir. I say it just rename it.
Oh, yes, sir. Okay. Then, yeah, I was actually looking for a large-scale automated classification of white blood cell images. Ali Hussain. Okay, they are absent, right? Okay. Are they absent? A large-scale automated classification of WBC images? Okay. Syed Hussain is there. Fine. Next, do we have Shivatri Nayak, Amit Desai?
Yes, sir. I'm present.
Okay, thank you. Do we have Azmita?
No, ma'am. No, sir. I'm Shivarti Naik.
Okay, okay. Yeah, fine. Thank you.
Yeah, I'm the main author, sir.
Okay, okay. Thank you. Yeah. Next, yeah, you can see Azmita also there. Fine. Sahil Sayed is also there, right?
Yes, sir.
Yeah. Thank you. Yeah, this was just confirmation how many participants are yet to be present. So we have almost 1, 2, 3. The presentation remaining for the day. I think.
Hello, sir. Hello, sir.
Kunal Deka I need to do, and Harshad, Syed, Javed Hussain, and 2 more, like 3. Let me just mark it off, and then so I can call them.
Hello, sir. Can you hear me?
Yeah. In the meantime, you can start. Thank you. Please go ahead, Gargi.
Hello,
Yes.
sir.
Hello, sir. Okay, so good afternoon, everyone. Today, I, Gargi Gore, student of College of Engineering, Pune, is presenting variable steering mechanism for automobile applications in association with Harshad Karochikar, Dikvijay Chavan, Piyush Deshmukh, and myself. Okay, so the presentation includes design, simulation, and introduction, design, simulation analysis, results, conclusion, and references. So for the Indian road conditions, we have considered for off-road applications in which there are various dynamic track challenges, out of which specifically maneuverability requires faster response steering. Hence, we developed variable steering mechanism using elliptical pinion and curved rack, giving us required variation in steering effort, making it easy for the driver to take tight turns at low speed. Benefits of using non-circular pinion over circular pinion will give reduced feedback, steering effort reduced towards the lock position, proper and easy maneuvering, and variable ratio will ensure variable sensitivity as we steer from center to lock position. So for designing the elliptical pinion, we generated the pitch curve. The main equation governing the relationship is R1 theta 1 plus R2 theta 1 is equal to E, where both R1 and R2 are functions of theta 1, that is angle of rotation of elliptical pinion. Then teeth profiles were generated for module 1.5 and pressure angle of 20 degrees. Methodology used was that non-circular pitch curve divided into several circular arcs with different radii of curvature and center of rotation, and then generating the teeth as a sequence of connected parts of several circular gears, where each tooth of the resulting non-circular gear corresponds to a tooth of a circular gear with same radius of curvature, module, and standard pressure angle. And correspondingly, each part of rack was also designed for the respective circular gear. Firstly, the evolute of the ellipse was generated using these equations, which represents the center of rotation of the series of circular arcs of the pitch curve of the elliptical pinion, and combined to give rack of variable radius pinion. Here, it must be noted that pitch curve is an ellipse, while the other curves, tip, root, and base curves are not. The base curve represents the evolute of the involute teeth profiles of the elliptical gear, which can be obtained by these equations. These are the respective curves of teeth. Then, semi-minor axis of the ellipse was adjusted to get an integer number of teeth using Kirchhoff's software. So, in this way, elliptical pinion of semi-minor axis of 16.2 and semi-major axis of 18.2 with 24 teeth was generated. For generation of rack, the methodology used was that as pinion moves from major axis to minor axis, the effective radius of pinion from center decreases. Pitch curves of both gears should match in order to have proper measure. So, the height of teeth on the rack was increased in succession as the pinion moved from major axis to minor axis. Amount of height increase was decided by difference in the distance of the point of contact of different pinion teeth, that is at pitch curve. So each tooth on rack would be at distance of perimetric difference in teeth of elliptical gear. The image shows the required pitch curves of the rack and pinion for proper meshing. Now to determine the required angle of pinion rotation for vehicle, perimeter of elliptical pitch curve is 108.16 mm. Per quadrant, it will be 108.16 by 4, that is 27.04 mm. The required curved rack displacement is 28 mm. Hence, the steer angle for center to full steer is 93.55 degrees. So as we can see, using elliptical gear, the effective radius reduced from 18.2 to 16.2, resulting in reduced steering effort from 2.64 kgs per hand to 2.35 kgs per hand. So to verify the meshing and dynamic characteristics of steering mechanism, Adams simulation was done, giving proper joints and contacts. The motion of the mechanism was analyzed by the graphs obtained. So as we can see, for constant torque being applied on the pinion, we get variable velocity of the rack as an output, as the graph of velocity of rack versus time is not straight but curved, which proves that the constant force applied, we can get variable output, making the mechanism more sensitive. Then to check the structural compatibility of the steering mechanism, as we have considered off-road application, we performed static structural and transient analysis using FEA software ANSYS to check the stress, strain, and safety factor of the tooth upon extreme force applications. In transient, the force was given in time steps, and the stresses coming on the tooth of the elliptical pinion, stresses coming on the tooth as the elliptical pinion rotates and meshes with the curved rack is analyzed. So it is clearly evident that in both the analysis, the safety factor is more than 1, proving the mechanism to be safe. So conclusively, with this mechanism, there is 11% decrease in required steering effort as we move from center to lock position as we steer for tight turns. So we get quick steering with reduced effort. As the off-road application brings feedback force to the driver in bumps, feedback also reduced to 11.11%. And effectively, if we consider constant force from driver, the tangential force applied on the rack by the elliptical pinion increases from major to minor axis, that is from center to full steer position, making it more sensitive. These are the references that helped us a lot in designing this variable steering mechanism. Thank you.
Yeah, am I audible? There were some technical issues from my side. Gargi? Hello?
Yes, sir, you're audible. You're audible.
Sorry, there was some technical issues. I just logged out and then logged in. Sorry for the inconvenience. Yeah, please, we'll go ahead with the next presenter then. Hi. So now I would like to call upon Tanvi. Tanvi Lige. Do you have Tanvi?
Hello, sir.
Yeah, Tanvi, can you present?
Yeah, sir, I will present.
Yeah.
Okay, screen is visible, sir?
Yes, please go ahead.
Just a second, sir. Okay, so good afternoon, everyone. I'm presenting the paper for the audio pattern recognition, and I'm from COIP. So the content for this, we are giving this shortly introduction, then problem statement, objective, proposed design, data set creation, results, then contribution for this work from my side, and then conclusion, and then reference. So what is a pattern recognition? So pattern recognition is the one of the thing in which we can create the acoustic scenery about the audio, where we cannot visualize the scenery, or it is we can say that calculating the presence of the audios, which defines the classes for the particular sounds. So from the research, we can say that the aim for to expand the scope and the improvement of the performance of the audio pattern recognition. Then research is done on the previous research is done on the denoisation and the emphasizing of the space, and our research is for the focusing on the detecting and the detecting of the pattern of the audio. So main objectives are to study the different methods and algorithm for the separation of the audio. Then we are proposing the one algorithm for the RPA, and then we are done the techniques for the audios, and it is for the real time purpose also. So for this, we have created our own data set. For this, we are collecting audios from the videos as well as the audios, and we converted into from one particular file format. Then we cleaned the data, and as we want, whichever classes we want, we collect it from that, and we make it audio into the 4 seconds audio, and make it to the one file of that whole audios of 1 meg CSV files. So this is about the data creation. So for this, we are using the CNN architecture, which is a part of the artificial intelligence or deep learning, we can say that. So for this, firstly, audio waves are converted into the spectrograms. So what is a spectrogram? Spectrogram is a visualization for the audio, in which the 3 parameters are checked, which is the first one is the frequency, then amplitude, and another is the time. It shows the frequency and the amplitude of the audio at a particular times by a visualization. So this spectrogram is given to the CNN architecture. CNN architecture is just one particular architecture in which we extract the features and created the feature maps and give the to the classifier to classify the particular classes of the audios. As we can see here, it will generalize the sound into the different classes. Actually, it was means if we are giving this some sound, it defines it. The sound is classes into the car horn or something, a dog barking or something in work. So this is like output of our audio pattern generation, in which the classes are shown with the confidence of their classes. So I gave one input for that. So there are the different audios in that. So it classifies the mostly sound is going in the class of the gun shoot. So it is the sound of the actually gun shoot. So for this, in this data set, we have created the 4,000 number of the audios, and after these are the audios are classified into the 10 classes basically, and this is the graph for that graph for classes audios. So we can see that there are the, as per I told that there are the 10 classes. So I make the 10 folders for that, and 9 folders for training purpose and one for the evaluation purpose. So for total training data is 3935 audio files, and for the evaluation, for the testing purpose, we are giving the 262 audio files to the model. So this is the confusion matrix for calculated for each class. So as we can, what is the confusion matrix? Confusion matrix is, we can say that the checking the particular accuracy for the each classes, not for the overall, but we are calculating the class to class accuracy, in which I'm giving the 20 audio files to for the check ones, which are actually for the of the ambulance, and model is taking that 60 of that 20, 16s are correctly calculated like a ambulance class. So this is one of the confusion matrix for the model. And for my contribution for this, I collected a 4,000 data set for this, and I trained it on the CNN model. And from this, I can conclude that this is a very useful data set for this, and the accuracy of the data set on this model is 94.50%. So these are the some reference. Thank you.
Thank you for your presentation. We'll go ahead with the next presenter. I would like to call upon. Yeah, one second. So Javed Hussain.
Sir, I am here.
Please share your presentation.
Understand.
Please share your presentation.
Okay. Sir, am I audible to you?
Yeah, you are audible and your video, I mean, your present visible. If possible, turn on your video, sir.
Okay, sir. Sir, my name is Session-2, a research scholar at JJTU. My project is under the guidance of Dr. Sivakumar Ramamurthy. Paper title is Study of Column Structure Behavior with Ferro and Fiber Reinforced Confinement under Compression. I would like to highlight some points such as abstract, introduction part, literature review, experimental methods or methodology, experimental procedure, results and discussion, conclusion and references. In abstract, 4 points I want to cover. First of all, we should know what is concrete. Concrete is nothing but one of the backbone of construction. It has several remarkable qualities, include high compressive strength, moldability to any shape, layable cost, aesthetic pleasing appearance, weathering action, etc. However, it has some drawbacks, including poor tensile strength and ductility strength. These drawbacks can be overcome by placing some reinforcement. The issue of low tensile strength can be resolved. Concrete reinforced with confined ferrofibers give high ductility structure that can be used to build earthquake resistant structure. Concrete is only building material utilized next to water. Ferrofiber cement is a thin composite form of cement matrix reinforced by closely spaced tiny diameter wire meshes rather than large diameter rods or large size aggregate. The typical thickness of ferro cement is in the range between 25 to 50 mm, used to enhance the strength properties of concrete. As we can see under this screen, such wire meshes which are used under ferro cement. The square welded meshes, square woven mesh, hexagonal expander mesh, steel fibers are also used to prepare the concrete, glass fibers, synthetic fibers, and natural fibers. Under introduction part, we'll go through ferro cement and fiber. We should study first of all what we mean by ferro cement. The word ferro cement refers to a type of reinforced concrete that differs from ordinary reinforced or pre-stressed concrete, principally in the distribution and arrangement of reinforcing component. The placement of the reinforced create a composite material, the behavior sufficiently distinct from traditional reinforced concrete in terms of strength. Ferro cement is nothing but it is an eco-friendly, sound technology, possesses excellent unique mechanical properties such as good tensile strength, improved toughness, water tightness, resistance to cracking and loss, and material effective construction technology. Fiber, on the other hand, fiber is nothing but it has also used to strengthen brittle material. Fiber is a tiny bit of reinforced material with a specific distinct qualities. The resistivity is significantly increased by fiber. The post-cracking resistance is much more reduced. Literature review, third part. Behavior of hybrid ferro-fiber reinforced concrete is an article placed by Syed Shoaib et al. In the year 2014. Under their study, they show that discontinuous fibers such as geofibers or natural fiber could be utilized as an additional reinforcement to check the ferro cement ductility, load-bearing capacity, and crack width. Fiber addition enhances the ductility of ferro cement as well as a result of the small matrix of fiber, strong bond with the mortar mix matrix and the reinforcement mesh. The tensile strength and ductility of the material have improved. The study also allows the testing and comparison of various mortar mesh and layer thickness combination. The cracking behavior and ultimate strength of concrete were greatly increased by the addition of steel fibers. The article, which has been placed by M.B. Verma and M.B. Hazare in the year 2015, article naming ferro cement composite material and its application, as ferro cement is an innovative material and the readily availability of material and easy construction method is suitable for the housing, water, and food storage structure. Ferro cement is found to be suitable material for repairing the defective RCC structural element. To increase their performance, it is necessary to determine the ideal mesh property range because the performance of ferro cement depends on the mesh reinforcing qualities. A significant alternative to RCC and repair material in the future because of its special characteristic is ferro cement. Objective of the study, the main objective of this experimental work is to study the behavior of ferro cement specimen under flexural and impact loading, in which welded square mesh and steel fiber has been used as a reinforcement. The various parameters considered under this studies are: first point, to compare the compressive, flexural, and impact strength of fibers ferro cement used using steel fibers. A specimen with ferrous cement with or without steel fiber specimen to increase stiffness and resistance to cracking than the conventional ferrous cement, to increase flexural strength and energy absorption capacity. Experimental methods or methodology used under this project. In this experimental program, 2 types specimen as steel or GI galvanized iron wire for lateral and longitudinal reinforcement were casted to check their behavior under axial loading in digital compression testing machine of 3000 kilonewton with sensitivity of 5 kilonewton per second. What casting material used is as follows. First point, steel bar 6 mm diameter size bar was used as a lateral ties and longitudinal reinforcement for column. Galvanized iron wire of iron, longitudinal reinforcement and lateral ties of galvanized iron were used as a diameter of 4 mm GI wire. Before proceeding to this experiment, some test has to be carried out. Test on fresh concrete, such as slump test. As you can see in this figure, it is clearly shown that a concrete is to be placed over this bone and its slump is checked. If it is good, then it resemble in the shape, and the concrete, if it is weak, it resemble in the form of shear crack. If concrete is poor, then it get collapse. The workability characteristic has been shown over here. Under this table, it can be shown no slump means 0, very low slump is in the range between 5 to 10 mm, low 15 to 30 mm, medium 35 to 75 mm, as high is shown under this figure. Compaction factor and corresponding slump has been shown on under this table. Table is nothing but resembling the strength properties of concrete. Here in this table, if you see, 18 samples are being there. First, plain cement, 6 mm diameter, 0 mesh, diameter of bar is 6, number of specimen conducted is 3, number of mesh layer to the column is 0. Such sample, such as concrete fiber with 6 mm diameter, 0 mesh, plain concrete with 6 mm diameter with 1 mesh, such samples have been prepared. Concrete fiber 6 mm diameter with second 2 layer of meshes, plain concrete with 4 mm diameter, 0 mesh has been prepared. Such samples have been prepared and it is brought under testing. Under this experimental procedure, it has been clearly mentioned that experimental program was designed to study the behavior of circular column of size 150 mm diameter and 300 mm height of a cylinder has been prepared. In this table, which has been shown, the same experimental procedure has been listed under this. If we go on counting, it will come to up to 54 columns. If we just count to this number of specimen, 18 into 3 is nothing but 54 columns. Now, the fabrication process, how the concrete has been brought under testing. Fabrication process is nothing but reinforcement 6 mm diameter rods, longitudinal bars and lateral bars has been casted in the form of frame, and here we see that without mesh and with mesh, with single mesh and with double mesh, concrete has been poured under this case and is tested under the compression testing machine, and its strength properties has been checked, and we find that the strength compared to plain reinforced concrete and to that of the with mesh with reinforcement, there is marginal increase in the strength properties. In this graph, it can be easily recognized that results and analysis of the experiment. Here in this graph, if we show it, the blue color line indicate that plain concrete with 6 mm diameter, 0 mesh. It has low compressive strength because graph is lying below. And if you go on seeing to the screen, in this concrete fiber with 6 mm diameter, 0 mesh, it has some remarkable increase in the strength. As we go on seeing to this graph, we can see that if we compare plain concrete with 6 mm diameter, 0 mesh and concrete fiber with 6 mm diameter, 2 layer of mesh, there are marginal increase. In the result, you can easily recognize that if concrete with plain without any mesh. If it is tested under compressive testing machine, it will give low compressive strength as compared to the concrete fiber with 6 mm diameter with 2 layer of mesh. Plain concrete with zero mesh, it is showing over here that graph is showing low characteristic strength, and a lateral strength is compared stress and strain, very low, and as compared to that of the concrete fiber with 6 diameter layer and 2 layer mesh, it has a marginal increase in the compressive strength. The graph, both graph doesn't, it shows that the resemblance. If we place concrete with zero mesh, there is a decrease in the strength, and if we place concrete with 2 layer of meshes, there is a remarkable increase in the strength of concrete properties. The conclusion part. Under the conclusion, the design become most fitted for the structure which is subjected to the earthquake and nuclear technology, nuclear energy plant. The spalling mixed mortar is considerably reduced by the addition of recon 3-year synthetic polypropylene fibers. With the rise in within the specific surface factor, the development in the strain is more pronounced. With the rise in SSR, there is an improvement within the stress strain behavior of the specimen, showing in more ductility. Addition of fiber. Yes. Addition of fiber in plain concrete has improved the compressive strength up to 22.5% as compared with that of the plain concrete. Means, under this conclusion, we are easily recognizing that if we make an addition of fiber and ferrocement, there is a marginal increase of compressive strength, that is up to 22.5 as compared to that of the plain concrete. Stress strain behavior of confined ferrocement shell fibers is healthier as compared to the plain concrete. The peak stress strain value improves within the rise with the rise in confinement of ferro fiber reinforcement in concrete. Design structures are highly seismic resistance. Means it is protecting to the environment in much larger scale. These all are the references. I refer to this Dr. Logan P. Fisher, moment capacity and crack behavior of cement in flexure, Journal of Article ACA, K. Srinivasa Rao. These all are the references which have been referred. Yes,
thank you, sir, for your presentation. It was a great presentation. We will now go ahead with the next presenter for the day. Please share your details out there for the question and answer sessions. If people have, they will get in touch with you.
Oh, okay, sir. I will share it. Okay,
thanks a lot. Thanks a lot. Now we'll go ahead with the next presenter, Shivarti.
Yes, sir.
Yeah, please share your presentation, ma'am.
Sir, can you see my screen?
Yes, yes.
Okay.
There's a close button there. You can just close it so that we can see.
What is that?
We can't. There is some reading. We can't.
Yeah.
See.
Now can you see my screen?
Yes, yes.
Okay. Good afternoon. I am Shivarti Naik, and I will be presenting on malware classification system using deep learning technique. Okay, so this is the agenda. I will be discussing on introduction and motivation. Then I will be highlighting the literature survey, followed by objectives, methodology, block diagram, the results, advantages and disadvantages, applications and references. Malware is defined. Okay, the introduction. Malware is defined as a malicious software designed to infiltrate or damage a computer system. Malware is a type of application that contains malicious executable code that can destroy the normal services and functions of a system or other applications. This software is created with the intent of stealing private information or spying on a computer without the consent of the user. Malware variants pose a major threat to cybersecurity and can cause huge losses to individuals and society. Okay, this is the literature survey. I'll just speak on this briefly. The first paper that I referred is malware classification using probability scoring and machine learning. Okay, so they have used VX7 website as a data set. Okay, and the features that were considered was API call sequences, n-grams. Okay, and they used CNN, SVM, RF, AdaBoost, NIBase, and KNN for classification. Okay, these are the results. Okay, and next paper is Al-Hydra. Okay, they have used virus chaser and Kiza as their data set. Okay, the size, count, entropy, entry point, IIT information, and so on were used as the features, and RF and multi-layer perceptron was used for classification. The detection rate obtained by them was 85.1% with standard deviation of 0.006. Okay, and true positive rate of 85.7% and a false positive rate of 16.1%. These are some more. Okay. So I'll come to the objectives. To present an efficient malware classification architecture using deep learning technique, develop a convolutional neural network model to classify malware samples into 25 families and achieve high accuracy with less computational power. Okay. Third objective is to adopt an approach that is data independent, to learn the discriminative representation from the data automatically, evaluate the performance of the method on a benchmark data set, that is MALMG, and study the detection effectiveness of the model in terms of accuracy, precision, recall, F-measure, and loss. Methodology. The malware classification process consists of 3 steps: input data set, data pre-processing, and classification. For input data, the MALMG dataset is used for the input data. The malware samples in the dataset are in the form of grayscale images. Each malware sample in the dataset belongs to one of the 25 malware families. Data transformation. The data is structured so that the classification algorithm can better process the data and performance may be improved. The input malware images are normalized to be suitable for the CNN model. Classification. Convolutional neural network model is used to perform the classification task. CNN automatically extracts the most important features from the images. The performance of the model is evaluated using accuracy, precision, recall, F-measure, and log loss metrics. Okay, so this is the block diagram. So first we have the malware data set. We divide it into training data and testing data, followed by data pre-processing, followed by the CNN model classification, and then the output malware class is predicted. Description of data set. MALMG malware data set is used as the input data. It consists of malware grayscale images belonging to 25 different malware families. Yeah, this is the malware sample distribution. Data pre-processing. The malware grayscale images are pre-processed. Grayscale images are normalized prior to applying it to the convolutional neural network. Images are resized to 64 cross 64. Normalization step was favorable for network training. Classification system. Convolutional neural network algorithm is used for malware classification. Convolutional neural network is a type of an artificial neural network biologically inspired by the organization of the animal visual cortex. CNN model can automatically detect and extract the distinctive and descriptive features from the malware images. These are the results. Confusion matrix. It analyzes the rate of success of the CNN algorithm. It compares actual target values with those predicted by the CNN model. Accuracy obtained is 95.73. This is accuracy versus malware family curve. It showed a high accuracy for most families. Precision. I have tabulated the values for accuracy, precision, recall, and F measure. So you can see the accuracy increased as the number of epochs increased. Training accuracy jumped from 70% after the first epoch to 90% after the fifth epoch. Initially, there was a gap between the training and validation accuracy curves, which went on decreasing with each epoch. The training and validation loss decreased to a point of stability with a minimum gap between the two final loss values. Okay. These are the advantages. Applications. Yeah, these are the references.
Thank you, ma'am, for your wonderful presentation. Please share your details with respect to email ID out there in the chat box. We will now go ahead with the next presenter, Azmita.
Hello, sir. Hello.
Please share your presentation, ma'am.
Okay. Whether my screen is visible?
Yes, yes.
Okay. Okay, good evening all. My topic is decentralized and fixed control of microgrid for electric vehicle charging station. And I'm a MTech Power System Engineering student. Then introduction. The whole world is moving towards a source of energy which would never exist in the future. So there is a need for finding a solution for this problem. The electric vehicles are considered as an alternate solution. Then a decentralized control method that helps in expanding the system by adding more power resources. Then the main purpose of the decentralized control method is to keep the balanced power in the charging station. Then a small intro about ANFIS. The ANFIS is the Adaptive Neurofuzzy Inference System, which is also a kind of neural network, which is based on a Takagi and Sajino fuzzy inference system. Here, the ANFIS is an intelligent system that can be used as an effective controller in energy management strategy. Then the ANFIS provides better accuracy and a better supervisory control even in complex real-time situations. Then the ANFIS controller uses the precise modeling concept, which is able to handle the highly complex nonlinear systems. Then the ANFIS controller is found to be more efficiency when compared with normal fuzzy logic systems. Then the problem identification. The major barrier of EV technology is size, number of batteries, and the economics of having a higher battery and using more number of batteries. Then the large scale implementation of electric vehicle, we have some challenges like EV acquisition cost are more higher than the internal combustion engines, and we have only a limited charging infrastructure. These are some of the limitations, and the high power demands in electric vehicle, which causes significant burden in the microgrid, which leads to some power quality issues. Then the conventional controller based on fuzzy logic systems, which are not involved in the precise modeling of the system. These are some of the problem identification. Then the research gap. The demand of electric vehicles will increase only when they come with some fast charging batteries with extended driving range. Then the required computational power is low in Coulomb counting approach for calculating the state of charge. Then the inaccuracy occurs, which is the cumulative error in the current integration is the major disadvantage in Coulomb counting approach. And the developing batteries with a high quality are the major concern. And the develop the battery with some concern like long lasting, safe, and which can store large energy. Then the cost for developing the energy storage system is difficult. Then the objective. Here, the major objectives are developing the ANFIS MPPT controller and the ANFIS EV controller. The ANFIS MPPT controller, which monitor the power extracted from the PV systems at a different temperature and different irradiance conditions. Then the EV controller, which schedules the charging and the discharging of the EV's battery with respect to microgrid frequency and battery's state of charge. Then to improve the system performance by ANFIS technique, which integrates the best features of fuzzy logic systems and ANN, which is nothing but artificial neural networks. Then to increase the efficiency of the energy management system, to increase the distance covered by electric vehicle. Then these are the proposed methodology. Here I'm using a solar panel. From the solar panel, we are obtaining PV voltage and a PV current. The obtained PV voltage and the PV current is given to ANFIS MPPT controller. Normally we have many techniques to extract the maximum power. Here I'm using the ANFIS technique with the help of PWM pulses. The obtained PWM pulses is given to DC-DC boost converter. From the boosted power is given to load. Here the excess power, we have to store the excess power in a battery. Here in order to save the power in the battery, we are using an ANFIS controller to maintain the state of charge. Then what is ANFIS MPPT controller? It is nothing but to design it is used to control the DC-DC boost converter. Okay. Then the ANFIS MPPT controller, which has two inputs, is nothing but irradiance and a temperature, and having one output. The voltage corresponding to a maximum power, which is the output. Then the voltage is compared with the actual PV voltage obtained from same temperature and irradiance conditions. Then the error, which is E, is obtained, which is nothing but the difference between two voltages, which is fed to the PI controller, which varies the duty cycle of the boost converter. Then this is the structure of ANFIS MPPT controller. The ANFIS MPPT controller, which has two inputs, which is temperature and irradiance, is given to a converter, and from the obtained error signal is given to PI controller. From we are generating the PWM pulses, the obtained PWM pulses is given to DC-DC boost converter. Then ANFIS EV controller. The ANFIS EV controller has been designed effectively to manage the output power of the electric vehicle integrated with microgrid, taking account of current SOC and EV battery of frequency deviations in the microgrid. Then load demand in the system is greater than the power supplied. The frequency is a nominal value causing negative frequency deviations. If the power supplied is greater than the load demand, then the frequency increases, which causes the positive frequency deviations. Then to keep the frequency deviations minimum, the ANFIS EV controller maintains the load or power generation in all instances of time. This is the structure of ANFIS EV controller. The ANFIS EV controller has having two inputs, which is SOC and the DELF. DELF is nothing but frequency deviation. Then it is from where we are getting a power reference signal, which is nothing but the power to be charged or discharged to the ith vehicle of time. Then we are giving the obtained error signal is given to PI controller, from which we are giving to DC-DC buck boost converter. Then how the flowchart for the ANFIS EV controller, how the electric vehicle EV charger works. Then this is a simulation diagram. The proposed work here we are having E and DV. From here, we are using the Session-2 technique because ANFIS, which works on Session-2 technique, and obtained here we are using the triangular membership function. Now here, the input first membership function, which is E. Here we are taking negative very large, negative maximum, negative small, 0, positive small, positive maximum, positive large, positive very large. These are the membership functions. 9 membership functions we are taken. And the second input membership function, and these are the obtained output. Here in output, we are maintaining the output value in 1. Okay, normally the PWM pulses are maintaining at 0.95 to 1. Then the irradiance, for the irradiance, we are taking as 1000 as the irradiance and the temperature as 25 as a constant level. Then the input voltage, here we are maintaining the input voltage as 99 volts. Then the current is about 15 ampere. Then the total power, we are obtaining the total power from the solar panel is almost about 1500 watts. Before obtaining the ANFIS controller, we are getting 1500 watt as the total power. And once after applying the ANFIS controller without any deviation, we are getting a straight line as 1500 watts. Then the battery voltage, here we are taking the battery voltage as 24 volt. The 24 voltage is also maintaining. The battery current, which is negative value, because our battery is in discharging state. That's why our battery is comes in a negative deviation. Then the battery power is also a negative value due to the discharging of the battery. Here SOC is dropping from 50. Then the conclusion is about 2 different smart ANFIS controller has been designed, which is nothing but ANFIS MPPT controller and ANFIS EV controller. The solar irradiance and the temperature changes are the 2 main variables which affect the PV output voltage and current. These problems are minimized with the help of ANFIS controller. The ANFIS EV controller effectively controlled the charging or discharging of the electric vehicle. These are the references which I have taken. Thank you.
Thank you for your wonderful presentation, ma'am. So, please share the details out there. We will get in touch with you.
Okay.
And yeah, we will now go ahead with the presentation. The next presenter, I'd like to call upon is Sahil.
Yes, sir.
So please share your presentation.
Yes. Sir, is it visible?
Yes, it is visible. Please go ahead.
Good evening, everyone. My name is Sahil Sayyed. I am from Ramrao Institute of Technology under the ambit of D.Y. Patil deemed to be university. And my paper topic is design of bandpass and bandstop filter using metamaterial inspired fracture square patches metal and its complementary, guided by Dr. Ayush sir. Next is the outline. So in this presentation, I will cover this topic: abstract, introduction, literature survey, development of bandpass filter, importance of fractal geometry filter, bandstop filter with fractal square metallic patches of second iteration, application of metamaterials, conclusion and references. So next is the abstract. So in this paper, a study of metamaterial has been inspired, comprising of the different arrangement of the square metallic patches, whereas the complementary geometry regarding the terahertz which are shown. So regarding the different alignment of the unit which has been which has the complementary structure, and where the responses which are discussed below that, some responses which we are get like bandpass, and some are some response which are bandstop. So the regarding that regarding the bandpass which has with some values which I get regarding the bandpass which has the center frequency at 210 gigahertz and 3 dB bandwidth is in between 207 to 213 gigahertz, and maximum insertion loss is minus 9.5 dB, and roll-off factor is passband of the bandpass is minus 2.16 dB per gigahertz. And regarding the bandstop filter response which we have get in the below graph, which is which is having the center frequency is 105 gigahertz and 3 dB bandwidth is in between 86 to 121 gigahertz, and maximum rejection level which is at minus 17.5 dB, and roll-off factor is minus 0.76 dB. And some response which we have get which are dual bandstop filter, which is also having the center frequency 155 gigahertz and 210 gigahertz, 3 dB bandwidth which is in between 152 gigahertz to 157 gigahertz, rejection level which we have got in the graph was minus 17.38 dB and minus 56.69 dB, and roll off factor was minus 0.5 dB gigahertz to 1.5 dB per gigahertz. So next is the introduction regarding the metamaterial. The metamaterial is any engineered material to have a belonging that aren't discovered yet in clearly occurring materials. It checks whether the structure, so feeding technique plays an important role on the impedance matching, which will lead to the maximum power transmission. Whereas the metamaterial are the artificial electromagnetic media that are structured on the sub-wavelength scale. They provide the optical property that can be reproducibility shaped on the length scale, but it is having the wavelength of the light. Metamaterial that are not found in the nature but endowed and entirely unaccepted property which they are having. And light are all about us. Wave from radio station that are all about us. So these are the psychic possibility or example of electromagnetic waves. So whereas the metamaterial are also composed of the periodic array of the resonance structure with the sub-wavelength dimension of the dielectric substrate. And regarding the terahertz region, considering attention was very interesting in the with the help of the terahertz region, where it is having the bandwidth and high top transmission, outstanding prevent rejection level regarding the imaging and communication purposes, and regarding the structure and so on. Whereas this paper present the metamaterial inspired terahertz bandpass and bandstop filter to the two response which you get in the single layer geometry purpose, which is in the form of the graph pattern, whereas the resonant pattern which is in polymer thick film, where it is inside it consists of the copper thin film, where on it we have get the bandpass and bandstop filter structure. Whereas the next is the literature survey. So these are some research paper which I have referred for regarding the metamaterial as well as bandpass and bandstop filter. So the first paper is a novel metamaterial slow wave structure with a larger space charge limited current. So in this paper we have discussed about the metamaterial and slow wave structure, whereas in order to find out the entropic and to improve the uniformity of the electromagnetic waves, so how the two metals have been coupled with the complementary split ring resonator geometry. So after that, next is the terahertz bandstop filter. So in this paper, I got the idea regarding the multi-layer microscopic structure consisting of the loop resonant that has been exhibited characteristic of the bandstop filter, whereas the multi-layer microstructure can be modulated between the two bandwidth, and it having the cutoff frequency as well as center frequency, which is having the same filtering effect of the polarization. Whereas the third paper, which is flexible dual band bandstop metamaterial filter with terahertz region. So in this paper, I got the idea regarding the dual bandstop filter as well as bandpass filter regarding the terahertz region. So in that I have got idea regarding the simulation of the console multiphysics simulation software. And fourth paper was the realization of bandpass and bandstop filter regarding the terahertz region. It means how to fabricate the copper thin film and simulation work on the console software which we have done. So regarding this purpose, which we have done on the thin film. So next is the development of the bandpass filter. So the first paper, so the figure number 1 is illustrating the development of the proposed complementary factual square shape bandpass filter. So this is the factual square patch metallic filter which you have got. And the dark area is a figure shows that a metal copper with a conductivity rho equal to 5.8 into 10 raised to s per meter, whereas it has a relative permittivity epsilon r which is 3.5, and thickness of the dielectric layer which is 60 micrometer, and thickness of the top metallic surface which is 80 micrometer. Where in the second diagram, the length 1 and length 2, length 1 which is equal to 400 micrometer and length 2 which is 320 micrometer, and width which I have got 80 micrometer, and the periodic array which I have got as 1800 micrometer as shown in this diagram. So this is the simulation which we have got in the console software. Whereas the figure number 2 which we are illustrating that the diagram, it is geometry with a different dimension of the proposed complementary factual square shape of the bandpass filter, that where the length 1 which the size of the L1 is 420 micrometer, whereas the L2 is 320 micrometer, and width is the 80 micrometer, and total periodic array which is denoted by P which is 1800 micrometer, which we have taken the values regarding the simulation work, and where the graph which we have get for the bandpass filter is figure number 3, which is illustrating the S parameter response for the complementary factual square shape bandpass filter. So I got the result of that also, and which is at the center frequency which is at 210 gigahertz, and 3 dB bandwidth is 207 to 213 gigahertz, and maximum insertion loss is minus 9.5 dB. where the roll-off factor which is of the bandpass is minus 2.16 dB per gigahertz. Where the second next is the simulated current distribution of the fractal square shape band for the bandpass filter. So this is the current output which we have got regarding in the console software regarding the fractal square shape of the bandpass filter. So next is the so in the figure number 4 as I showed before. So in that we have got some result whereas the 126.32 gigahertz which is discovering a robust electric discipline uniformly distributed alongside the edges of the resonance structure, whereas the at this value 177.32 gigahertz, the extensive value of the electric subject symmetrically distributed along the left side proper side of the resonance shape. Moreover, the higher electric power and the discipline concentrate at the corner of the resonance shape take place. Whereas the next topic is the importance of the fractal geometry filter. So in this in this topic, the fractal geometry filter, the fractal square shape of the metamaterial take place. Where the figure number 5 is illustrating the schematic diagram of the bandpass filter using four square shape metallic patches of the complementary. Where while doing simulation, we have taken the four square shape metallic patches. The size was 320, and after that, after simulating that, we have get the diagram. Means output of that. The figure number 6 is illustrating the simulated S parameter curve of the complementary four square metallic patches, and some values which I have got regarding that was the center frequency and as well as the 3 dB bandwidth and maximum return loss which I have got at 9.5 dB. Regarding that, which cause a poor performance of this filter. So it will be the major impact as compared to the band pass filter, the low pass filter. So after that, next is the figure number 7, which is showing the alignment of the square shape which is responding to the bandstop filter. This study investigates the effect of the square metallic patches without any fractal shape. Whereas the we have taken the rejection level, which we have got the rejection level which is at 12 dB in the figure number 8 while simulating this. Whereas the figure number 7 is illustrating the schematic diagram of the bandstop filter with four square metallic patches. After simulating that with taking the size of the 320 micrometer, the figure number 8 which you have got through the software, console software, the simulated S parameter curve for the four square metallic patches which you have got. And whereas the next topic is the bandpass filter, bandpass filter with the help of the second iteration. So in this topic, since the fractal geometry has the greater effect on the performance of the filter in the next level of the iteration, so it helps for the improvement. Whereas the figure number 9 is illustrating that the original diagram of the fractal square metallic patches with the help of second iteration which is done by me, and whereas the with the help of the console software I have simulated the S parameter also in the form of the graph which is a normal square metallic path, and got some values regarding it was the band stop response which is at 105 gigahertz, and whereas the minus 3 dB which is cutoff frequency which is at 86 gigahertz to 121 gigahertz, and bandwidth which we have got at a center point which was the 35 gigahertz, and maximum rejection obtained which was 17.5 gigahertz, and second iteration which we have got with the help of the resonant frequency of the filter which is very lowered. And so that's it. After that, next is the application of metamaterials. So the major application of the design of bandpass and bandstop filter using metamaterial inspired fractal square patch metal and is complementary is a major application of the design and application of the metamaterial surfaces in microwaves. So in microwaves it takes a major role in the application purposes. So it is using biomedical application as well as in military applications, as well as in benefits of the antenna and flowing aerospace packages, light and sound detection filtering to control the moderate and sound alerts, whereas it has the ultrasonic sensor detection to cause shade, as well as nano scale wrinkles of the metamaterial are also used. And after that conclusion, so in this paper we have got some responses while doing the metamaterial for the fractal square patch metallic path and its complementary part. So while simulating, we have got some responses as bandpass and some responses as bandstop. While finally the development of the square metallic patch, a metamaterial filter with the fractal geometry, which was investigated. So in the first case, as I have shown before, that the fractal geometry metallic patch provides a bandpass filter, and the second case was showing that the 4 metal non-fractal square patches as 4 complementary non-fractal square patches as are investigated through the simulation of the console software, where it shows the better performance of the filter that the fractal geometry is desirable for the filter, whereas the non-fractal metal square the patches provide the bandstop filter, providing the non-fractal complementary metal patches similarly providing a bandpass filter. So these are some so I got some values of the bandpass and bandstop filter with the help of the graph. So a detailed description of the development of the proposed bandpass filter and bandstop filter is showed in the table number 1. So these are some values which I have got regarding the bandpass and bandstop filter. The filter, the bandpass fractal, bandpass non-fractal, as well as bandstop non-fractal, bandstop fractal with second iteration. It's a center frequency which I have got through the graph, as well as 3 dB bandwidth, as the rejection level, which is the return loss we can say. So these are some values which I have got with the help of the graph while doing simulation on the console software. And so these are the references so these are some Excel paper which I have go through it and got some idea regarding this paper regarding the microwaves, metamaterial, etc. So that's it. Thank you.
Thank you, sir, for a wonderful presentation. Well, good. We have come to almost end of the presentations now. Do you have Kunal? Are your
Yes, sir.
technical issues solved? Are you ready to present?
Yes, sir.
Kunal Deka?
Yes, sir.
Yeah, will you present now? Yeah, we can hear you now.
Yeah.
Please share the
Yes,
screen.
sir. Is it visible, sir? Am I audible?
Yes, you're audible and the presentation is visible. Please go ahead.
So hi, my name is Kunal Lekha. I'm doing my master's from Amrita School of Engineering in Oil Electronics and Drive. So my topic for today is analysis of bidirectional buck boost quality converter using fuzzy logic and neural network control. So the basic family of converters such as classical boost and buck boost can provide a theoretical high voltage gain with the use of extreme duty cycles. But these converters face the issues of reverse recovery of diode and power losses. Quadratic converter adds more advantages to conventional DC-DC converter by high voltage gain. The proposed quadratic buck boost converter is bidirectional in nature and reduce the output voltage spikes and minimize the charging and discharging ripple. So from the recent study, we can find that the quadratic buck boost converter can be used when extreme low conversion ratio required while operated at moderate duty cycles. Combination of quadratic boost and zeta converter can inherently recover energy of leakage inductance. Double zeta quadratic converter containing basic switching cell responsible of quadratic gain gives high efficiency and less switching stress. Combination of quadratic boost converter and SEPIC technology gives voltage gain higher than that of conventional quadratic boost converter. Voltage gain also can be enhanced by voltage lifting capacitor as seen in interleaf quadratic boost converter. So my objective is to develop a control method and operate in different load conditions to check the feasibility of it and to check if it is work as a bidirectional power flow and make an adjustment so that it can be used as for application of electric vehicles. So in the left hand side, we can see the block diagram of the buck boost converter. Power flow is from load to battery and battery to load. And on the right hand side, we can see the control closed loop control block diagram. This is the circuit diagram of the buck boost converter. It consists of two inductors, four switches T1, T2, T3, and T4, and two diode and RC circuit in both input and output side. So in the right hand side is the block diagram of closed loop. So in the first phase in open loop boost mode, so first when T2 is on, energy transfers from battery to load, battery to L1 and from capacitor to L2. And when switch T2 is off, energy stored in inductor L1 will be transferred to capacitor, and from inductor L2 it will be transferred to load. And this is the operation waveform of the converter in boost mode. So as we can see, The voltage across inductor L1 will be Vs. Voltage across inductor L2 will be Vc. When the switch is on, we can see increasing nature of inductor current L1 and L2, and the current through capacitor is minus L2, and the current through diode will be L1. The current through switch T2 will be difference between L1 and L2. So this is the mode of operation in buck mode. For this, we are controlling switch T1. So when T1 is on, energy from the battery will be transferred to L2, and from capacitor it will be transferred to L1. When T2 is on, T2 is off, energy from the this one inductor L2 will be transferred to capacitor, and from L1 it will be transferred to the battery. So this is the operation waveform of the converter in buck mode. So the inductor will L1 voltage across inductor L1 will be Vs, voltage across inductor L2 will be Vc. We can see the decreasing nature of inductor current L1 and L2 when the switch is off, and the increases when the switch is on. The current through capacitor is minus L2, the current through diode is minus L1, and the current through T1 is difference between L1 and L2. So in the closed loop for fuzzy control, fuzzy logic control design based are widespread knowledge of plant and do not need the exact mathematical model, and designed to alter varying operation point. To control the output voltage, Mandami system interference is used. Input variable error, the change in error, and the output variable U, which is PMW duty cycles, are used to fuzzy system. The two inputs are divided into 7 groups: negative big, negative medium, negative small, zero, positive small, positive medium, and positive big. So we can see the plot of membership function for error, change in error, and output variable. So this is the error and change in error. It is the rule base for error and change in error. These are the duty cycles I am giving. For neural network, artificial neural network is known for fast response, fast behavior, and robustness. Its self-adjusting capabilities can be adjust and variation, nonlinearities and uncertainties in the system. Having similar to human brain in two ways: acquiring knowledge by learning algorithms and storing data with semantic waves. So this is the simulation results in the of the boost mode in open loop. We can see when the switch T1 is on, there is an increasing nature of inductor current L1 and L2. Like this goes for all capacitor and diode current. This is the result for buck mode. This is the result for boost mode in fuzzy logic. This is result of boost mode in neural network. This is for buck mode in neural network. This is the code I have put in the neural network model. This is the comparison result. We can see for reference voltage 90, I'm getting 189 in fuzzy logic, 188.1 in neural network. I'm getting best in in neural network on 200 volt. I'm getting 99.8. This is the comparison of buck mode. We can see like for 45 volt, I'm getting 44.15 in fuzzy logic and 44.28. So conclusion, the proposed buck boost converter has less component compared to traditional converter in buck boost mode. RC filter reduce the spikes in output voltage and also reduce ripple during charging and discharging. For boost mode, input voltage is taken to be 48 volt, and buck mode, the input voltage is taken as 200 volt. Neural network control, fuzzy logic control, and PI control has been implemented to stabilize the voltage in load side and to check the feasibility of the controller. For the comparison table, it can be seen that PI controller can be output voltage close to reference voltage. Although I have not given here the PI controller, but we can clearly see from the buck mode, the neural network is far working better in buck mode, and in boost mode, the logic control is getting better. So the application is charging and discharging of electric vehicle. Bidirectional converter can be used for UPS for uninterrupted power supply, AC and DC drives, power system operations. These are the differences I have gone through. That's all. Thank you.
Thank you for your wonderful presentation.